All right, let's dive right into this. Welcome to The Explainer. Today, we're embarking on the ultimate cosmic detective story. We're looking into one of the most profound, honestly, kind of chilling mysteries out there, our actual place in the universe, and the very real possibility that we aren't originally from here. If you love piecing together complex puzzles through structured information, you're absolutely in the right place. We're going to explore the mathematics of biology, astrophysics, and even some game theory to understand exactly why the night sky is so incredibly quiet.
Okay, let's set the scene. It's the summer of 1950. The brilliant physicist Enrico Fermi is just having lunch with his colleagues. They're chatting about the sheer scale of the universe, advanced alien tech, typical physicist lunch talk. And Fermi just suddenly drops this incredibly simple yet totally disturbing question. Where is everybody? Think about it. With billions of years of cosmic history, our galaxy should theoretically be absolutely swarming with extraterrestrial life. Yet, we see nothing. Literally nothing. No visiting spacecraft, no massive alien megastructures, not even a random radio signal.
To really wrap your head around why Fermi's question is so heavy, you've got to consider this mind-bending number: 3 times 10 to the 23rd power. That is the estimated number of stars in the observable universe. I mean, we're talking hundreds of billions of galaxies, and every single one of those has hundreds of billions of stars. And orbiting those stars, an unfathomable number of potentially habitable planets. It's a scale that just breaks human comprehension, right? Statistically speaking, the universe should literally be teeming with life. But when we actually listen to the cosmos, it's just a deafening, almost terrifying silence.
So that brings us to the formal definition of this mystery, the Fermi paradox. Essentially, it highlights the massive contradiction between the incredibly high probability of extraterrestrial life existing and the complete, total lack of evidence for it. Because look, here on Earth, life naturally expands to fill every single available niche, right? If an advanced alien civilization developed out there, given the billions of years the universe has been around, they should have spread across the galaxy by now. Or at the very least, left some sort of detectable trace. So, what exactly is stopping them?
Well, the most logically sound and definitely the most frightening answer to that is something called the Great Filter. The basic idea here is that there's some kind of cosmic barrier, a highly improbable evolutionary step that stands between a planet forming and a civilization actually colonizing space. This barrier is just so insanely difficult to pass that practically zero species ever make it through. So the million-dollar question is, where exactly is this filter located in the timeline of life? Let's map this out. Think about the required evolutionary steps to get to a spacefaring civilization. You need the right star system, then simple life, complex single-cell life, multi-cell life, tool-using animals, and finally, a space colonization explosion. The Great Filter has to be hiding somewhere in there. But honestly, getting to step 2, just sparking simple life, might be the impossible barrier. For decades, we've desperately searched the cosmos for alien biology, assuming life originated in the warm, primordial oceans of early Earth. But the mathematics of biology suggests something way more disturbing. The complex structure of DNA is so intricate, so perfectly engineered, that many astrobiologists argue it couldn't have just evolved from dead rock and water in such a short amount of cosmic time. And that brings us to the dark theory of panspermia. This proposes that the building blocks of life, or maybe even life itself, weren't forged on Earth. Instead, they were engineered in the deep vacuum of space. We're talking trillions of microscopic dormant biological seeds, cosmic seeds, drifting through the frozen cosmos right now on asteroids, just waiting to crash into a fertile world. Billions of years ago, a massive asteroid may have hit our barren planet, acting as a biological delivery system. It deposited these frozen extraterrestrial microbes right into our oceans. The extreme heat of the impact awakened the dormant code. It was literally an interstellar infection that rapidly multiplied, evolved, and terraformed our entire planet. Now, what's really interesting about this next concept is a wildly counterintuitive idea from philosopher Nick Bostrom. It sounds totally bizarre at first, but hear me out. Why on earth would a scientist actively hope to find absolutely nothing on Mars? I mean, most people would be completely thrilled, right? Finding alien microbes or fossils next door. But Bostrom argues that finding life on Mars would actually be the worst news ever printed on a newspaper's front page. Let me break down why that is.
Here's the chilling logic. If we find evidence that life evolved independently on Mars, it proves that going from non-living matter to simple life is actually pretty easy. Or it proves that our whole solar system is thoroughly infected by those same cosmic seeds we just talked about. Either way, if it happened twice just in our tiny little neighborhood, life must happen everywhere.
And if those early steps on our evolutionary timeline are easy, then the Great Filter cannot be in our past, which leaves only one absolutely terrifying conclusion. The Great Filter is an existential disaster waiting in our future. It means practically every advanced civilization out there ultimately destroys itself before it can conquer the stars.
This kind of existential dread leads us right into the rare Earth hypothesis. The science here brilliantly illustrates what researchers call the 30% rule. So it took Earth roughly 3.8 billion years to evolve our civilization. We only have about 1 billion years left before the sun's expanding luminosity boils our oceans and wipes out all life. If our evolutionary process had proceeded just 30% slower, time would have simply run out. Life on Earth fortuitously evolved just fast enough to beat the ticking clock of our very own star.
And man, that fast-tracked evolution wasn't just a smooth, easy ride. It required a totally insane sequence of lucky breaks. Just look at the staggering statistical improbabilities of Earth's history. The collision that formed our moon and gave us stable seasons, that was roughly a 1 in a trillion chance. Or the asteroid that wiped out the dinosaurs at the exact perfect time for mammals to rise, try a probability of 6.5 times 10 to the negative 15th. Our existence isn't just a given. We didn't just win the cosmic lottery. It's more like we found the winning ticket on the ground right as we were struck by lightning. Take the Endovonian tetrapod transition as another perfect example. Moving from aquatic fish to land-dwelling animals, that was a massive evolutionary filter. It required fish to somehow survive brutal mass extinction events, adapt to extreme environmental shifts, and potentially even undergo rapid genetic mutations triggered by a nearby supernova that stripped away Earth's ozone layer and blasted the planet with radiation. The sheer, stubborn luck required just to get life out of the water and onto dry land is absolutely phenomenal. When you actually multiply the probabilities of all these incredibly rare events together, researchers calculate that the odds of a civilization like ours arising are less than 1 per 10 to the 40th power star systems. Remember, there are only about 10 to the 23rd stars in the entire observable universe, so this overwhelmingly suggests that the Great Filter is safely in our past. Space is silent because we are likely the only planet in the observable universe that actually managed to run this crazy gauntlet. But wait, if that panspermia theory we discussed is true, it changes the entire definition of humanity. It means your DNA, the genetic code beating inside every single cell of your body right now, is an extraterrestrial import. We are not the native sons and daughters of Earth. We are the direct descendants of ancient alien microbes. The aliens we've been desperately looking for out in the stars, they're staring right back at us in the mirror. But what if we actually aren't alone? What if the universe is completely full of life, but we just can't see it? This brings us to a terrifying alternative straight out of science fiction and game theory, the dark forest hypothesis. This theory suggests that extraterrestrial civilizations are out there, but they're deliberately staying quiet. They're hiding out of a deeply ingrained fear that broadcasting their existence will inevitably lead to their rapid, immediate destruction by a more technologically advanced, highly hostile civilization. So, the crucial point is, the logic behind this fear is based on the unyielding axioms of cosmic sociology. First off, survival is the absolute primary need of any civilization, period. Second, civilizations constantly expand, but the resources in the universe are completely finite. They run out. Finally, because space is so ridiculously vast, communication is incredibly slow, which creates this massive chain of suspicion. You can never, ever truly know if another civilization is benevolent or hostile, and they can't possibly know your intentions either. Under these specific conditions, you have to imagine the universe like a dark, dense forest at night. Every single civilization is an armed hunter, stalking quietly through the trees. If you hear a twig snap in the dark woods, you don't flip on a flashlight and yell, "Hey, I'm over here," not unless you want to be someone else's dinner. The only mathematically logical move for your own survival is to strike first and eliminate the potential threat before they can eliminate you. This framework perfectly and terrifyingly explains why our radio telescopes hear absolutely nothing. Broadcasting your location is practically a cosmic death sentence. The silence of space isn't empty, it's just terrified. And this brilliantly illustrates the incredibly high stakes of the crossroads humanity is at right now. We can chart our trajectory using the Kardashev scale, which basically measures a civilization's advancement by how much energy it consumes. Right now, we're a Type 0 civilization, earthbound. But research suggests that if we can just manage our resources and avoid blowing ourselves up, we could harness the entire energy of our planet, becoming a Type 1 civilization by the year 2271. And incredibly, if we keep going, we could even harness the total energy of the sun as a Type 2 civilization by the year 3500.
Which leaves us with the ultimate question for this explainer. In a dark and silent universe, what exactly should our next move be? If the rare Earth hypothesis is right, and we are completely alone, then our existence is infinitely precious. We have a cosmic duty to survive and spread the light of consciousness. But if the dark forest hypothesis is right, is our continuously expanding radiosphere of TV broadcasts and radar signals the single greatest mistake in the history of our planet? I'm going to leave you to ponder that one. Thanks for joining me on this explainer. Keep asking the big questions, and I'll catch you next time.